Hello, I am Paola Brugnara and I am a product engineer in Rotoblas. I am working in the development of soundproofing and air tightness solution. Today we are going to talk about acoustic performance of mass timber buildings. Before starting, we need to say that wooden structure, like all lightweight construction, do not have an high acoustic performance at low frequencies. This does not mean that timber buildings cannot reach a high acoustic performance. It means that we need to work on timber construction in a different way compared to traditional solution. We need to work with different principles, like the principle of disconnection, in order to avoid the transmission of vibration through the structure. Before starting, I would like to make with you a small experiment with a vibration speaker in order to understand since the beginning the meaning of the principle of desolarisation. We will use this particular type of speakers that transmit the sound vibrating, and it makes that the speaker turns any surface into a speaker. So we will try the speaker on different surfaces in order to understand how the vibration propagates to different materials. Okay, this test consists in using this particular type of loudspeaker. We will put that on different surfaces and we will hear how the propagation works. We will have OSP panel, we will have a metal element, and we will have metal element with resilient acoustic profile. I need to use this metal element because we need to load in the profile. So let's try. On wood. On metal element, you can hear that the frequency is changed. And with acoustic profile. Can you hear the difference between this one and this one? Now we will understand why it happened. Okay, before starting, I would like to clarify the relationship between ASTM and ISO standard, because maybe some of you is more familiar with ASTM metrics and others with ISO standards. ISO standards are recommended where there is no ASTM counterpart. During our presentation, we will use ISO 12354 and ISO 10848. Both of these standards does not have an ASTM counterpart. For this reason, the ISO standard will be translated to ASTM metrics. So the calculation will not change too much. In timber buildings, it is very important to consider the flanking transmission because it affects the final performance. If we install a wall into a building, we will not have the performance that we have measured in the laboratory, but we will have a worse performance. This is to the fact that we don't have just the direct transmission that we have measured in the laboratory, but we have also the flanking transmission, because the vibration produced into the building propagates not just through the wall that divide two rooms, but it propagates also through all the other part of the structure. And all this path in which the vibration propagates is called flanking transmission. If you are more familiar with ISTM metrics, you will have the same problem. So you will calculate the direct transmission and the flanking transmission. We already said that wooden structure, like all lightweight construction, do not have an high acoustic performance at low frequencies. And for this purpose, we need to stop the propagation of the vibration through the structure in order to obtain a reduction of the noise transmission. In order to do that, we need to use a resilient product, which are elastic separating layers between rigid elements whose main task is to prevent the transmission of vibration in the building structure. I have already anticipated that we need to use the principle of disconnection. So this construction technique that keeps elements isolated and separated in order to avoid the transmission of vibration and of the noise through the structure. The principle of disconnection consists in a mechanical model which is mass, spring, mass. The first mass is, for example, a wall. The second mass is, for example, the slab. And the spring between them is the resilient profile, so an elastic material. We will see that it is not just an elastic material, but also the material should have viscous properties. So from a mechanical point of view, the profile that we install between the two mass works like a spring and a damper. The elastic component of the material, which is the spring of the system, dissipate energy bouncing. And the damping component of the material stop the spring from the bouncing and transform the motion into viscous friction. Of course, it is important to have both of the components in order to have the dissipation of energy. If you think about the spring, you need to consider that it is very important to have the proper load applied on the spring, because just imagine that you to apply very high load on a very weak spring. This spring will be compressed and it will not work. On the other side, if you don't apply enough load on the spring, and the spring is very strong, the spring will not activate, and it will remain rigid. Another example that maybe can help you to understand the behavior of their profile and to the importance of the load. Just think about the shock absorber of the car. If you imagine to apply a shock absorber of a truck under a city car, you will understand that it will not work in the proper way. Or vice versa, if you apply the shock absorber of a city car under a truck, it will not work. So acoustic profile will work at the same way. We have discussed about, let's say, of the mechanical behavior of the system, but we can define it from an acoustic point of view too. So from an acoustic point of view, we would like to create a decoupled system in order to reduce the propagation of vibration into the system. We can define the system decoupled if the resonant frequencies is exceed. And so first of all, we need to calculate the resonance frequencies. here are formula that allowed us to calculate the resonance frequencies of the system. So first of all, we need to know the elastic properties of the material, which is defined with S, and then we need to know the load applied on the material, which is defined with the M. So it is clear that it is not possible to estimate the resonance frequencies if we don't know the load applied on the profile. And if we cannot calculate the resonance frequencies, we cannot define if the system is decoupled or not. For this reason, there are no acoustic profile that can work without knowing the load applied on them. And here an example. For example, for many types of acoustic profile, instead of using the formula, we use graphs. So first of all, we need to define the loads. It is very important that the building has very good acoustic performance during the normal life of the building. It is not so important to have a very good acoustic performance at the ultimate state. For this reason, it is important to estimate the load considering the real condition. We recommend to consider just the dead load without any coefficient and half of the leaf load without any coefficient. This allowed us to have an estimation of the load closer to the real condition. After the estimation of the load, we can enter into the graphs here. Knowing the load, for example, 0.2 Newton per square millimeters, and we can estimate the natural frequencies. At this point, we can divide the design frequencies, for in this example 50 Hertz, to the natural frequencies. With this value, in this case 2.27, we can enter into the graph of the transmissibility and estimate the acoustic benefit. Sometimes you can find a table of use of the resilient profile. The table of use is defined considering that the profile should work between 20 and 30 Hertz. So in this case, the applicable compression is already is pre-calculated from us in order to have the minimum and the maximum value in order to guarantee that the profile will work in the range between 20 and 30 Hertz. This calculation that we have seen take in consideration the profile working, but it does not take in consideration the influence of the fastening system. For this reason, Rotoblas, in collaboration with the University of Bologna, have founded a measurement campaign in order to estimate the behavior of some typical junction in CLT buildings. All the measurements were carried out in compliance with ISO 10848, and the purpose of this experimental measurement was to define Kij for CLT junction. Before this measurement campaign, there were no experimental data on of Kij on CLT structure. Kij is the vibration reduction index, and it is important for the calculation of flanking transmission. In particular, we have already seen that if we need to measure the acoustic performance of a wall, we need to consider the direct transmission and the flanking transmission. The flanking transmission depends on different parameters. The first one is the type of structure. The second one is the type of finishing applied on, for example, on the wall. And then there is this Kij, which is, as I said, the vibration reduction index, and and it defines the influence of the connection into the propagation of vibration. So it is very different if we have walls and slab connected with many fastening system, if we have or not resilient profile, and so on. Same things is if you are used to calculate with STM metrics. So the formula is exactly the same. For the setup of the test, we used CLT panels produced by 7 different manufacturers in order to have an average value which was not affected by the type of CLT. Probably you already know that some manufacturers glue the CLT lamellas on 3 sides. Others producers glue the lamellas just on 1 side, and so on. We also tested CLT, 3-layer CLT and 5-layer CLT. We tested different junction, connection between wall and wall, and connection wall slab. We tested the different type of angle brackets and different type and number of screw. Of course, we also tested the difference of having and not having resilient layers. Here are some pictures of the test setups. We used the panels at real dimension. This was to have results that can be also used in the calculation. Due to the big dimension of the test setup, the test was carried out in our warehouse. For this reason, during the measurement, the temperature and relative humidity was controlled, and of course the warehouse was not working during the measurement. And here an example of X junction between 4, so the connection between 4 walls. And here a configuration in which we tested the performance of the slab. For the measurement, we used the shaker and the pink noise filter. And actually for the measurement, we use different type of shakers in order to have results that will not be affected by the type of instrument. Of course, all the measurements were carried out in accordance with ISO 10848. And here I would like to show you some results. We have done many measurements. I would like to show you just some examples in order to understand the meaning of this campaign. Of course, if you are interested, you can find more results in our catalog. So here, first example, it is an X junction between wall and wall, and between a wall we have installed this APDM profile. Actually, this product was designed for airtightness. When you have CLT site and you cannot tape the junction, you can put this compressible APDM between walls. But APDM is an elastic material, and for this reason we have tested it in order to understand what happened from an acoustic point of view. So here you can see the setup. So we have an X junction without construction ceiling, so without the acoustic profile, and then the same configuration in which is applied the construction ceiling. And here the results. As you can see, the Kij increases if we have the acoustic profile. I would like just to remind you that Kij is vibration reduction index. So Eiger is the value, Eiger is the reduction of vibration, Eiger is the acoustic performance. So in this case, we can see that if we add this elastic material between walls, we will have an increase of the acoustic performance. We have also tested a wall floor junction, and in which we have put and in which we have installed the resilient acoustic profile. So here the setup. So we have a wall and a slab. As fastening system, we have used partially 3D screws, and between floor and wall, we have installed the resilient profile xylophone. In this case, we don't have any load applied on the profile. I would like to remind you that from an acoustic point of view, it is a result from the safety side, because a profile which is not properly loaded will dissipate energies from an higher resonance frequencies, and so it will not have the best performance that it could. But even in this situation in which the profile is not properly loaded, we can appreciate an improvement of the acoustic performance. And so it is a very good result, because even if the profile is not properly loaded, it works and provide us a benefit. In my opinion, one of the most interesting results is the influence of the number and type of screws. We have tested the same junction and we have changed the number of screws and the type of screws. We will see that there is a lot of difference in the acoustic performance. In the first case, we have installed partially 3D screws and every 20 centimeters in a L junction, and the Kij is quite low, 5.5. If we reduce the number of the screws, the Kij increase. This is due to the fact that screws are rigid elements that transmit vibration. The interesting part is that if we change the type of screws, and instead of using partially treated screws, we use fully treated screws, we will have an improvement of the acoustic performance. In this case, we have the same junction. We have the fully treated screws installed every 30 centimeters, so they are closer than the previous example, but the acoustic performance is higher. As we already seen in the, if we use partially 3D screws every 40 centimeters, we have a Kij of 8.1. If we use fully treated screws every 30 centimeters, the Kij increased to 12.4. It is an interesting result, and it is due to the fact that we don't have the contribution of the head of the screw, which because the head bring the element to a closer contact, And of course, if we have this closer contact, the vibration will, for the vibration, it is easier to pass from an element to another. Of course, if we separate the screw, the acoustic performance will increase. In order to understand a little bit better these results, I would like to let you hear this YouTube video in which you can appreciate the difference of using different type of fastening system and using or not resilient profile. In the first example, you will hear different of the type of sound. So what is changed is the frequencies. In the second one, which is a wall-to-wall connection, we will change the type of screws. In this case, you will notice different of decibels. So let's say the volume of the sound will change. And in the third case, with and without resilient profile too, you will appreciate the difference. Of course, the performance of the acoustic profile will be better if we load it in the proper way. In that case, we have just the weight of the slab. In order to estimate all the configuration, we have also developed software in which is possible to define the configuration of our joint. In this case, the University of Bologna have developed an analytic method to combine the different measurement results in order to make it possible to define more configuration than the one that we have measured. This project was published in different conferences because it was a very innovative measurement that provide data that there was not available up that day. Of course, if you are interested in having more material, please contact us and we will provide you more information. The second step of our investigation was to understand the behavior of the structural behavior of the resilient profile. We have seen that the fastening system influence the acoustic performance. So the second step was to understand if the resilient profile affect the statical behavior of the fastening system. Because in this case we don't have a general connection, for example, steel to steel timber, but we have steel resilient profile timber. And according to this, we have noticed that the thickness of the material will influence the static performance of the fastening system. We have seen that having a resilient profile will not affect too much the final connection if the thickness of the profile is 6 millimeters. If we have 7 millimeters, the decrease of the static performance is quite high, and for this reason we have chosen to have a very stable material that is only 6 millimeters thick. We have also certified the values for an ETA, so in order to have recognized value for the angle brackets in combination with the acoustic profile. Please note that these values are calculated, and in that case the notified body considered the acoustic profile as air, and it caused a quite high reduction of the static performance of the profile. We have also measured the shear resistance of a connection timber to timber. And here some results in which we can see that if we don't have pretension, the connection timber to timber has a better shear performance. But if we have some pretension, so if we applied some loads on the connection, the connection timber xylophone timber has higher or at least the same shear resistance of a connection timber to timber. This is due to the fact that we have a contribution of the friction. For this reason, we have tried to estimate the friction between wood and xylophone. We have tested different configuration in order to understand if some of these parameters influence the friction. So we have tested with different wood moisture on different CLT surface, narrow and side face, in order to simulate a connection between wall and the slab. We have tested it with different materials, so spruce and birch. We applied different normal force, and we tested with different xylophone hardness. Of course, friction can be considered only if there is a perfect contact between wood and xylophone. If we don't have this perfect contact, of course, friction will not activate. And here the results. We have noticed that wood moisture, CLT surface, counter material does not influence the friction. Normal force does not affect the friction. The important thing is to have a little bit force in order to guarantee the perfect contact. What affects the friction is the type of xylophone and the hardness of the profile. The static friction decreases with xylophone hardness, of course. When we developed the profile, we have chosen a material that is very, very stable, because we need to remind that the profile is installed inside the building, and that for this reason having deformation, creeps and so on will affect also the static performance of the building. So from a mechanical point of view, we have chosen a material that does not have a creep, actually. As you can see, after first the deformation, which is due to the load applied, we will not have an increasing of the deformation. And then we have also chosen a material that have a very linear deformation. This is very important, because if we don't estimate the load in the proper way, we need to make sure that the profile will not be affected by a different load. So of course acoustic performance will change and so on, but from a static point of view we will not have problems. The profile will be installed inside a timber building, so the fire behavior of the product, it is also important. We have tested the xylophone installed exposed to a flame and protected by 2 different type of sealant. And here the results. As you can see, there is no big difference between using or not using the sealant. And what we can see is that the profile, let's say, burns at the same speed of wood. So having the profile or not having the profile, it is the same. And in our opinion, it is very important to guarantee the stability of the building if we will have a fire. Because here the results of the test, we have stopped the test after 60 minutes, and we have seen that there will not have an increase of the temperature on the unexposed surface, and we have seen that there was no smoke on the other side of the building. We have also made some homemade tests in order to understand the behavior of the profile in different conditions, like here with water. So we have put the profile, different type of profile in water, and we have then take a look in what happened after that. Xylophone is a monolithic mixture of polyurethane, and it will not absorb water compared to other type of profile in foam or cork. And it is very important because the profile will not bring water inside the structure. So even if it rains or this kind of stuff, the profile will not work as a sponge. And this is very important for the durability of the timber building. At the end, when we design and study a resilient profile that need to be installed inside the structure, we need to consider the acoustic performance of the product, and we have seen how to do that. But we need to take in consideration that there is the influence of the fastening system. In particular, we have seen that fastening system influence the acoustic performance, and then that the type of acoustic profile that we choose influence the static performance of the connector. It is important to find a balance between these two elements, because if the resilient profile affects too much the static performance of the building, we need to increase the number of fastening system, and having a lot of fastening system affect the acoustic performance. So it is very important to find a balance. We need to remember that the profile will be installed inside the structure. For this reason, it's very important to guarantee a very stable material with good mechanical performance that will not affect the durability of the building, and if it's possible, that have a good fire reaction. But of course, working on the flanking transmission is not enough to guarantee a good performance of timber structure. It is very important to guarantee a reduction of the direct transmission. Same as if we talk about ASTM metrics. For this reason, Rotoblas have measured some typical solution for CLT. We can see that we can work on the finishing. For example, here is a solution with CLT exposed, and here the solution in which we have added a suspended sealing, and we can see that we have an improvement of the acoustic performance. And here an example of how the detail matters. We have a solution in which we have installed a resilient profile between plasterboard panels and the structures, and we can see that this elastic material that separates the plasterboard increase the acoustic performance of the partition. This makes perfectly sense because the plasterboard panels vibrate, but the vibration will not be transmitted to the structure because there is an elastic material that dissipates part of the energy. And so we can see that we have, in this case, a benefit of 4 decibel. Another technique is to increase the superficial mass of the partition. In this case, we have coupled the plasterboard panels with a bituminous, very heavy membrane, and increasing the superficial surface and increasing the loads of the superficial surface increase the acoustic performance of the partition. So before we have 54, and then we have 59 decibel. Now I will show you a calculation of the influence of the openings. So the results are given according to ISO standards. Actually, the result will not be so different if you are used to work with ASTM. So I think that the example can be easily understood for all of you. So first case, we have a wall without openings. So the performance of the wall and the performance of the facade will be the same. So what we have, let's say, measured in the laboratory, and it will be more or less the same that we will have at in the final building if we had the flanking transmission, of course. But if we add a wall, no, sorry, but if we add a window, we will have a reduction of the acoustic performance, especially if we choose a poor window. In this case, we have this, but we have added a window which has a air of 30 decibel. The final performance of the facade will be 38 decibel. The problem is that in this case we cannot work on the wall, so it does not make sense to improve the performance of the wall, because in the case 3 we can see that we have installed in the wall some improvement, and we have reached 60 decibel, but the final performance have not changed because we are always around 38 decibel. This is due to the fact that noise can pass through the window. What we need to do is to work on the window, and we need to choose a better performance of the window. So if we have the same wall as before, so 48 decibel, but we have increased the window performance to 38 decibel, we have an improvement of the performance of the facade up to 45 decibel. So, and this was the only way to improve the final results. Of course, the installation matters, and be careful about the details. For example, installing the window, avoiding a direct passage of the air will increase the acoustic performance of the partition. Because I would like to remind you that air is one of the main mediums through which sound waves propagate. So, of course, also the installation of the window matters. I would like to remind you that it's very important to use the appropriate solution to avoid the propagation of the sound waves through the air. So it is important to seal the connection between window and structure. In conclusion, I would like to remind you that in order to reach good acoustic performance in timber construction, it is important to choose right material and working on with tested solution and adding elastic material and plasterboard panels and suspended ceiling and so on. It is very important to work on flanking transmission, because keep elements isolated will reduce the transmission of vibration. And then be careful on the details in order to guarantee a very high performance. So air tightness is very important to avoid the propagation of the sound waves through the air. I would like to thank you for your attention. Here is my email. If you have more questions, you can write me. Thank you.
So thanks, Paola, and thanks for you all listening and watching. I understand that unfortunately there has been some issues with the quality of the video. On my laptop, it plays perfectly. So what we will do, but we checked in the next door, Lawrence checked, and it was not good also within our office on a different computer as a receiver, as an attendee. So what we will do, we will, instead of uploading the recording of this webinar for the video part, we will upload the actual video from Paola, and you will get the full quality. So please, now Milos Slavic is joining me in the Q&A session. We don't have much time, but we really welcome your questions, if any.
Thank you, Paolo. Thanks for everyone coming today. And I just want to add to Paula's presentation that, you know, we at Rotoblas, we do take the timber constructions a little bit to the next level, or if you may want seriously. So as you saw, it is a complex topic about soundproofing. It is about the detail. So I do suggest to work with acoustic engineer or to us to write us your question or queries. We can help. We do not design the actual acoustic performance, but we definitely help with your question and queries. This is the catalog of one of our product lines, which is only dedicated to soundproofing. So please feel free to contact me, and we can send you a copy or discuss your next project. We do have also 2 projects completed in Australia with the xylophone, which you saw in the presentation. They are awesome projects. They both university student accommodations in Melbourne. So one way or the other, if you have a chance to visit these projects, that's definitely a good chance to see how a good building performs.
Yeah, and I may add that at least for the La Trobe Uni student accommodation, there have been some on-site acoustic measurement performed after the construction was completed by Marshall Day. So I think it will be possible to access this data if anyone is interested. But the main scope for us and for Marshall Day is being able to calibrate their software predictions based on real data from as-built projects. And this, I remember, was a key information and knowledge that also in my past experience in Italy provided a lot of help, because currently the software are not calibrated for timber-based materials. They are born and calibrated for heavier materials and stiffer materials. And timber, we know it's intrinsically better from the acoustic point of view, at least in the medium and high frequencies. It has, as Paola pointed out at the beginning, a little of limitation in the low frequencies, intrinsic to its nature of being a lightweight material. But the solutions are available and ready, and there is evidence also from testing on site. So we have now a question from Scott Jeffrey Earnshaw. It looks like wood can perform well, which is very interesting. Do you think there are industry unmet needs for improvement to composite or engineer wood panels with a noise cancelling glue? That's an interesting proposal. Yes, there will be. If there is such a product, a noise cancelling glue, the whole industry will be more than happy to know about it and test it, and if possible, start using it. Why not?
Yeah. I mean, the amount of disconnection between 2 materials, it's a key. And also, you see that when we performed the test and there was not a resilient profile in between, the KIG was quite low. And as soon as we introduce something which disconnects the 2 materials, it's always, performing then better and better. And even I was, quite surprised how a fully threaded screw, which has a conical head, works against a screw which has a washer head screw, right, design. So details, it's all about the details.
Yeah, well, probably because it distributes on a much higher surface the whole vibration effort that gets to the screw.
Correct.
Yeah, that's interesting. So Scott, you really excited our curiosity, and if you know about any noise cancelling glue, that will be a wonderful thing for the whole timber industry. Mass timber and lightweight. Yes, as I said, the only gap that we have, and we are filling the gap with appropriate product, is at low frequencies. But we are improving. The whole sector is improving and providing.
I feel, if I may add, I feel that from the interest or what we get, the inquiries about soundproofing, we are still not there yet. It's been overlooked by many builders, and I may say, it costs extra money. That's for sure. But if we are, wanting to improve the product, the final build, then we have to look at these details, and we have to give answers to the occupants. Okay, if they come back to us with a question, okay, what have you done to improve the quality of my build? So if I want to say, yeah, we definitely have products. Anything is available now. let's improve even the low frequency builds.
Yeah, and coming back to my experiences in Italy and to these recent experiences here in Australia, where we measured both a mass timber building after it was built, the latrobe, and also a stick frame built, the 5-story, the green apartment block in what is called Parkville. Okay, in both cases, the results from on-site tests were better than what was predicted. So there is caution from the acoustic engineers in designing with timber correctly, because they have less experience. They had less experience. Now some of them starting to have significant experiences and test results. So, but anyway, this precaution has resulted in better than estimated outcomes, which is the correct way to go, of course. And well, another point is about the durability of these damping systems. As Paola pointed out, they did run some fatigue tests with many cycles, which equate to, I had a look, it equates to 9-10 years, what they've done. But anyway, as you remember, the profile is flat, so there's no expectation of any decrease of the performances, even with longer durations. Okay, then, if there's no more questions, we thank all of you for being with us into this webinar, and we look forward to having you watching our In Focus videos that explain how it's made and how it works. Also on acoustic designs, there's a nice video that really goes through the principle of acoustic design. And our next webinar, which will be after Easter on Tuesday, 13th of April at 11 a.m., will also have a very interesting subject: how we can build Australia's future 7-star homes, with timber, of course. We will have Dr. Philip Christopher from Melbourne Uni joining us as a speaker into this exciting webinar. And meanwhile, I can wish you on behalf of us all happy Easter, and see you soon.